So the Chapter 9 test will be the next 2 days. I don't know if you'll need the whole 2 days, but I'm not going to ask you the identities that you see up on the board, but you have to know those identities. So I have found just writing them down sometimes is just a good tool to memorize them. So make sure you know your Pythagorean identities. Sine squared plus cosine squared equals 1. 1 plus cotangent squared equals cosecant squared. Tangent squared plus 1 equals secant squared. Know your reciprocal identities, that the sine is 1 over the cosecant, the cosine is 1 over the secant, the tangent is 1 over the cotangent. Know your quotient identities, that the tangent is sine over cosine, the cotangent is cosine over sine. You also have to know your unit circle. That is not something I will provide. I will not provide these or your unit circle. So please tonight take the time to look over those things and study those things before you come in for the test.
I literally got like black pimples on my face out of nowhere, and then I was like, Alexa's like, do you want to see it? Because I went down there to get microphones for a video.
Everybody got these?
1 second.
Okay.
He was like, can you retake it? I said, really? And I actually pretty okay that day, so I was like, literally like, so I don't know if I should see it.
Now we are not going to do all of these problems. I've picked out the ones that I feel kind of are most like what we're going to see on the test. So as we skip some, just go ahead and cross those out. I don't expect you to do them. You do what I do. That's what you're going to turn in when we're done with class today. Okay. So let's start out with number 1. It says find the value of each expression using the given information. So all this does is use the reciprocal identities. So number 1, if the cotangent is 12 over 5, then the tangent is 5 over 12. Number 3, if the tangent of alpha is 2 over 3, then the cotangent of alpha is 3 over 2. So that's a great place to start. Very simple, nothing fabulous. Because those are reciprocals, then you just get to flip them over. Okay, so that would be our reciprocal identities. It's nothing more fabulous than that. Okay. Let's take a look at number 2, where it says verify the identities. Now on the test, there is only one identity, but it is worth 20 points. So be concerned about that. But if you take a look at problem number 1, you can decide to hold either side. It is your call. I don't care what side you decide to manipulate. But I like that that is something very simple. I know that -2 secant squared is the same as -2 over the cosine squared. So I know that I can kind of shoot for that. So what I'm going to do is, since the right side is what I'm holding, it only has one term, that tells me I need to add those fractions together. So we're going to write these fractions. I'm going to separate them a little, and I'm going to write their denominators in parentheses since they're more than one term. And I'm going to multiply the left fraction by sine of y plus 1 on top of bottom. And I'm going to write the right fraction by sine of y minus 1 on top and bottom. Because my goal is to have a common denominator. Now, if the denominators are very different, and if multiplying them doesn't get you anything more simple, don't do it. These ones, they are conjugates. So I am going to multiply those denominators together. If I multiply sine of y plus 1 and sine of y minus 1, they're conjugates. They always get a difference of squares. So you will always get the first term squared minus the second term squared. So sine of y plus 1 times sine of y minus 1, a plus b times a minus b is a squared minus b squared. Now let's do our multiplication on top. This is 1 times that quantity. So that's just going to be that quantity, sine of y plus 1. This, be careful, there is a negative 1 in front. So distribute that negative. So it's going to be negative sine of y plus 1. Now, usually what happens, there's something on top that either simplifies, cancels, or can be substituted. Here, our sine of y and our minus sine of y are opposites. Great. Here, our plus 1 and our plus 1 can be combined to become a 2. So we've already found the 2 that was in the original, which is great. Now remember, negative 2 secant squared, you should always keep in the back of your mind, what is that? That is negative 2 over a cosine squared. So I have a Pythagorean about sines and cosines. I know that sine squared plus cosine squared is equal to 1. So cosine squared is 1 minus sine squared. It is not sine squared minus 1. Those are different things. But in algebra, if you multiply top and bottom of a fraction by the same thing, if I multiply by negative 1 on top and bottom, a negative 1 turns a subtraction. So you can actually get a turn subtraction just by multiplying the other part of your fraction by negative 1, or putting a negative 1 in front, however you want to think about it. So now we get a precise match. 1 minus sine squared is cosine squared. And that's exactly what we wanted, because what is the reciprocal of a cosine? The secant we were searching for. So we get negative 2 secant squared. That is our answer. So our answer is negative 2 secant squared of y. We found that. Remember, you don't touch one side, you only manipulate the other side that you have decided to manipulate. And you can use any of those rules that we wrote down from the first page. Are we good with that? Does that make sense with that one? Okay. I'll let that sit there for a minute. Make sure you got it. And if you have any questions, make sure you let me know. So the trick there is you are allowed to turn a subtraction as long as you multiply by negative 1 on the other spot. No, just cross it. So on these, remember, if I skip it, you skip it. We're only doing certain ones of these. Well, things like this could be on the test, yeah. Okay. Now, if you could, we're going to skip number 3, but if we could do number 4. It just so happens on this one that the right side does seem to be pretty simple. So I'm going to think about that as 1 over the cosine. And that's what I'm shooting for. Now on the left side, I have lots of trig functions to work with. If I have lots of trig functions, the first step you should do is to turn them all into sines and cosines. So by the quotient rule, I know that the tangent is sine over cosine. Now I'm going to give myself a little bit of room, and I'm going to kind of do a similar trick that we saw before. I'm going to multiply the left fraction by the right denominator and vice versa. Okay. Now, here is an example where our denominators are of no use to multiply them together. Now remember, our answer is 1 over a cosine. So we want this cosine in there. We just want to find a way to get that to cross out. Okay, now let's look. If we distribute on top, remember, we're distributing that sine to both of those. We get sine of theta plus sine squared of theta. If we multiply these numerators together, we get cosine squared. Does anybody notice something that popped into our equation? Yes. Sine squared plus cosine squared is equal to 1. So that is replaced with a 1. Now remember, we wanted this 1 plus the sine to cancel out. 1 plus the sine plus the 1, they're exactly the same thing. So we can cancel those out. Now, here's where some of you try to make up some rule of algebra somehow magically that you shouldn't. Remember, sine plus 1 divided by 1 plus sine is the same as like 7 divided by 7. What is 7 divided by 7? 1. You're going to put a 1 in that place. And what is the reciprocal of the cosine? Secant. Which is the answer we were searching for. So there's just a practice. But I would suggest going back to 9.1, looking at your 9.1 notes, looking at some of the 9.1 AB practice homeworks, watching the video again. 9.1 is one of the most difficult of our sections from chapter 9. Okay. Do we have any questions about number 4? Okay. These ones down here, 1 and 2, we're going to only do equations that are on the interval from 0 to 2 pi. Include the 0, don't worry about the 2 pi. So we're talking about, just think about it on the unit circle. We don't have to do that plus 2n pi for these, okay? So let's look at our first one, number 1. If the only trig function in the entire equation, they all match, that's what we're going to make our u. So I'm going to take out the cosine and I'm going to replace it with u. And then I'm going to ask myself, okay, how do I solve that equation? Well, we need the u's to one side. So subtract 3u from both sides. We need to divide by that coefficient of -2 to get an answer of 1. Now, once we get to the point, yeah, it's just a standard equation. Yeah. And then we're going to put the trig function back on only once we've solved for what that variable is equal to numerically. So we get the cosine of x is equal to 1. Now, at this point, you ask yourself, where on the unit circle would the cosine of x be 1? The cosine of x is equal to 1 only at 0 radians. So the answer is 0. So number 2 is the same sort of tactic. We only have one trig function in the equation, so let's let our u for that one equal the sine. So we would get 2u squared minus 1 equals 0. Now that's kind of factorable if you use the square root of 2, but I would suggest for this one, just add 1 to both sides, divide by 2, and what are we going to do to get rid of the square? We're going to square root. Now what do we have to put in front of the square root symbol? Plus or minus. Now let's talk about how we square root a fraction. To square root a fraction, you want to square root the top and square root the bottom. Now we don't leave anything unrationalized on the unit circle, so we will never leave a square root of 2 in our denominator. So if we pop it to a top and leave a normal 2 behind, that's what we're talking about. So once we have numerical values for our variable that we chose, we're going to put the sine of x back in. So we get the sine of x equals plus or minus the square root of 2 over 2. Now, the sine and the cosine are both square root of 2 over 2 at the 45s. The plus or minus includes every single quadrant, so we don't really have to think about the quadrants. We just need all the pi over 4s. So our answer to this one is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Any questions about that? Okay. We're going to skip number 6. We're going to look at number 5. So if we're going to do this, I would get it equal to 0 by moving that 1 to the other side. And then ask myself, hey, can I factor that? Well, because we have secants and we have tangents, there's no way to factor that. But we do know a trig identity that says that secant squared is equal to something good related to tangents. Secant squared is equal to tangent squared plus 1. So that can come out and be replaced with a tangent. Now everything is tangents. So now is a good time to use a u substitution for our tangent. So every place we see a tangent, we're going to replace it with a u. So tangent squared would be u squared. Tangent's just a u. The 1 and the negative 1 cancel each other out, leaving us just with u squared plus u equals 0. And once you have it as simplified as possible, then ask yourself, is it factorable? Well, this is one where we have a greatest common factor. What do they both have in common? A u, so we can factor out a u. Now be mindful when you factor out that u that you need a 1 in this spot right there, because you need to be able to distribute and get what you started with. So you can always check a distribution, did I do my factoring correctly? And then once we have it factored, remember we set each factor equal to 0. And once we have the numerical quantity, then you stick your trig function back in. So this is where is the tangent of x equal to 0, and where is the tangent of x equal to negative 1. Now let's analyze that for just a minute. Remember that the tangent is y over x, or sine over cosine on the unit circle. So a fraction is only equal to 0 if the top of it's 0. So we want where is the sine? So this also says where's the sine equal to 0. That's really what you're asking. Well, the sine is equal to 0 in 2 places, at 0 and also at pi. Now let's talk about the tangent. Where does the tangent of x equal negative 1? The tangent equals 1 at the 45s. Specifically, it's going to be negative in quadrant 2 and quadrant 4. So the 45 in quadrant 2 is 3 pi over 4. The quadrant 4 45 is 7 pi over 4. Now on the quiz, or on the test, I will give you a blank unit circle that you are welcome to fill out or not fill out, but it will be a blank one available to you. So then you can have that as a resource. Do we have any questions about number 5? So there will be 4 equations, I believe 2 equations on the test. They are 10 points each. Okay, there are 2 equations. Everybody good with those? Okay, I think we still have some people copied down, so I'll give you a moment to get yourself caught up and make sure if you have any questions, that we can answer those.
Will you have any extra of those unit circles, so like I can have one to practice it before the test?
If you come back later, yeah. I don't right now. That's all I got. Okay, everybody good? Okay. Now we're jumping to the sum and identity, or sum and difference identities. We're only doing the ones that are nice, like problem number 1. But you can look at any of those. Let's look at problem number 1. the cosine of negative 15, you're going to find anything on the unit circle where if you do the math, you get negative 15. So I'm thinking I'm going to do 45 minus 60. 45 minus 60 is negative 15. Okay, now from here, remember the formula. If you look at the difference formula, it's right here. Okay, it says that the cosine of alpha minus beta is the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. So this is going to be our alpha. This is going to be our beta. So it is going to be the cosine of 45 times the cosine of 60 plus the sine of 45 times the sine of 60. So it's just a matter of plopping now in our information from our unit circle. At 45 degrees, our point is square root of 2 over 2, square root of 2 over 2. That's the coordinates for our point. At 60, we are at the point 1/2 square root of 3 over 2. So all you got to do is use those values from our unit circle. So we will plop those in. So if we apply what we know about the unit circle, this would be square root of 2 over 2. The cosine of 60 is 1/2. The sine of 45 is square root of 2 over 2. The sine of 60 is square root of 3 over 2. So please simplify this down until we have one fraction as our answer. This would be square root of 2 over 4 plus square root of 6 over 4, which is square root of 2 plus square root of 6 all over 4. Now, if you decide to use, say, 30 minus 45, 120 minus 135, whatever you decide to use, you will get that same answer. You might get square root of 6 plus square root of 2 over 4. You might get the reverse of mine, but it's exactly the same thing. So you might choose different numbers than I did, but you'll still get the same value. So there are 2 of those on the test. I did a sine and a cosine. Okay. Now we're going to skip. We're going to skip all of that. We are jumping down to here. And the last thing that's going to be on the test are the double angle formulas. Again, your sum and difference identities, your double angle identities will always be on the board as a resource. That's not going anywhere. Okay. So let's look at finding the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta for the given value and interval. Okay. So the first thing I want you to do when you see a problem like this is draw your XY axis, label your interval that they're talking about, put a dot in that interval. You always connect it to the origin and the x-axis to make a right angle, and your theta is always by the origin. Then before I put any numbers in, because I'm going down, I'm going to put a negative here. Because I'm going to the left, I'm going to put a negative here. And my hypotenuse is always positive, so I'm going to put a positive there. Okay. Now, if we look at our tangent, back in the days of SOHCAHTOA, we know that tangent is opposite over adjacent, or y over x, however you want to think about it. This would be a 1, and this would be a 2. And then just check your work. Would negative 1 over negative 2 give me a tangent of 1/2? Yes, the 2 negatives should cancel, blah, blah, blah. Okay, so you've labeled it. Do not move on until you have all 3 sides of your triangle. We know that negative 1 squared plus negative 2 squared will equal our, well, they called it a radius squared, but our hypotenuse squared. So 1 plus 4 is our radius squared. Our radius is always a positive, so that's square root of 5. That's one case where you don't need the plus or minus. You might put the plus or minus if you're missing one of the legs, because that plus or minus is determined by what direction you're going. Okay. Once you've done that, I need to know the sine, the cosine, and the tangent in that location from that triangle. So I don't apply any formulas yet. I'm just doing SOHCAHTOA. I already were given the tangent, but sine is opposite over hypotenuse. Now let's rationalize that. So that would be negative square root of 5 over 5. Let's do the cosine. That would be negative 2 over radical 5, which is negative 2 radical 5 over 5. Okay, so we have the sine, the cosine, and the tangent. Okay, now that we've done that, we are ready to actually answer the questions that we've asked, which was find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. Now those are the formulas that are up on the board. So let's start with the sine of 2 theta is the formula 2 sine of theta, cosine of theta. Okay, the sine of theta is negative radical 5 over 5. The cosine of theta is negative 2 radical 5 over 5. Let's put those next to each other. And I'm going to write that 2 as a 2 over 1. Because the other ones are fractions, that's how you make that one look like a fraction. If we multiply everything on top, we get negative times a negative is a positive. So we get a positive 20. 2 times 2 times 5 is 20 over 25, which reduces down to 4 over 5. Okay, so that's just our sine of 2 theta. Now cosine of 2 theta is cosine squared minus sine squared. Now there's 2 other formulas. All of them are going to work. You decide how you want to do it. I don't care. You pick. So the cosine was negative 2 radical 5 over 5. We're going to square that. And the sine was negative radical 5 over 5. So to square a fraction, square the top, square the bottom. Negative 2 times negative 2 is 4. Square root of 5 times square root of 5 is 5. 4 times 5 is 20. 5 times 5 is 25. Do it again. Square root of 5 times square root of 5 is positive 5 over 25. 20 minus 5 is 15 over 25, which reduces down to 3/5. So it's just be mindful of your fractions. Be careful. You can use a calculator, but please remember that I want your answer in fraction form, not decimal form. And then finally, that gives us down to the tangent of 2 theta. I'm going to I want you to use, you can use the other formula, but just use the sine of 2 theta over the cosine of 2 theta, because we had to find those anyway. We have them all nicely done. They're nice and pretty. They're reduced as much as possible. So it would just be 4/5 divided by 3/5. And you can do big C over little c. Now I'm going to illustrate what happens in the big C over little c at this point, but watch what happens. We have a 4 times a 5 from the big C. We have a 3 times a 5 from the little c, so the 5s will cancel. And that's what happens if both big C and little c contain the same number, and we get an answer of 4/3. So that is the last type of problem that will be on the test. So there's going to be one verification, one like this, 2 equations, 2 using the sum of difference formulas, and then there's a bonus or 2. Okay. So please at this time, turn this in. Exactly what we did is what you have to do. You don't have to go further than that. Please turn this in. Get your points for it. Tonight, things to do. Watch this video again. Look over your unit circle. Write it out again. Do you know all those identities on the first page? Write those out again. If there's a certain type of section that is causing an issue, maybe you had trouble with 9.1, maybe you had trouble with 9.3, go back to those videos and watch them. I have all these resources for you, not just for the fun of it, so that's a great place to study. You are in an upper level math class, studying might have to happen. I know that that's foreign to you guys. In math, you guys always did good. You didn't have to study. Just look over everything before you come in tomorrow. Okay, so turn this in, get yourself some points. Please check to make sure that you have turned in your chapter 9 notes, your chapter 9 homework, some 9.5 A and B were due. Some of you haven't turned those in yet. Please check and see what you still have out there. I will be taking late work until probably the first few days in May. So there you go.